Hello everyone, I'm Sebastian Y and this is Managerial Economics. In this video I'm going to solve two practice exercises for simultaneous games. As always, I recommend that you try these exercises for yourself and then come back and watch the solution. In the first exercise, we are asked to draw up the normal form game matrix for rock, paper, scissors. The payoffs are +1 if you win, -1 if you lose, and 0 if it's a tie. Since we have 3 different actions to choose from, it's going to be a 3x3 grid. As always, I'm going to put player 1 on the rows and player 2 on the columns. Each player can pick rock, paper, scissors. If both players pick rock, it's a tie, 0-0. Same thing with both players picking paper and both players picking scissor. If player 1 picks rock, then they lose to paper but win against scissors. If player 1 picks paper, they will win against rock but lose against scissor. And finally, if player 1 picks scissor, they will lose against rock and win against paper. To find the Nash equilibria of this game, we need to mark the best responses. We'll start with player 1. If player 2 picks rock, the best choice is paper. 1 is better than -1 or 0. If player 2 picks paper, player 1's best response is scissor. If player 2 picks scissor, player 1's best response is rock. Going over to player 2, we can do the same thing, but go the other direction. If player 1 picks rock, the best choice is paper. If player 1 picks paper, best choice is scissor. And if player 1 picks scissor, the best choice is rock. We can see that there's no box in the matrix where both players are best responding to each other. This means no pure strategy Nash equilibria exist in rock, paper, scissors. No matter what the outcome, somebody always regrets their choice, and would have been better off picking something else. You're always better off switching to the play that beats whatever your opponent chose. The actual Nash equilibrium of this game is a mixed strategy Nash equilibrium where everybody randomizes what they pick, but that is beyond the scope of this course. For the second exercise, I've gone ahead and transcribed the normal form game matrix onto the screen. As before, I'm going to use red to underline player 1's best response. If player 2 picks left, then player 1 can pick up or down. Either way, they get 3, so it's a tie, and they are both a best response. If player 2 picks middle, up is better than down because 4 is better than 2. And if player 2 picks right, then player 2 will want to pick down. Going the other way, if player 1 picks up, player 2's choice between left, middle, and right will yield 6, 5, and 2. 6 is the best. If player 1 picks down, then player 2 is choosing between 7, 8, and 6. 8 is the best, so they would pick middle. Based on what we just did, we can write out the best response functions for the two players. So for player 1, if player 2 picks left, then pick up or down. It doesn't matter, it's a tie. If player 2 picks middle, then player 1 should pick up. And if player 2 picks right, then player 1 should pick down. The best response for player 2 is if player 1 picks up, then the best choice is going to be left. And if player 1 chooses down, then the best choice is to pick middle. The Nash equilibrium happens when each player is best responding to each other. We can see in the chart that that happens at up, left. Using the best response functions, we can also see this. Player 2's best response, if player 1 picks up, then pick left. And then if we take that left and go up here into player 1's best response, we can see that up is a best response there. So we have up and left being best responses to each other, and that is the definition of a Nash equilibrium. That's all there is to it. If you have any questions, feel free to let me know. Thanks for watching.